Hello. Welcome to this e-learning module.
Welcome. I am Rachel. Welcome to the course Working at Heights Part 1. This course is a part of the training program Working at Heights and Continuous Fall Protection. The first course, Introduction, helps you to understand the key definitions and the safe use guidelines for anchorages and horizontal lines. In this course, we will learn about the checkpoints to be considered before working at a height and the steps of continuous fall protection. We will also learn about some of the key fall protection devices and their correct usage. This course will enable you to list the checks on the personnel before working at a height, list the checks on equipment and work areas before working at a height, identify the importance of a permit and list the checkpoints for issuing a permit, explain the 3 steps of continuous fall protection, describe a personal fall arrest system, explain the safe use guidelines for retractable lifelines, ladder safety systems, safety nets, anchorages, and portable scaffolding. Identify the safety violations in the use of the fall protection devices. Describe the correct action for the safe use violations. Identify the most common and dangerous falls. A day in Irwin's life. It had been raining since last night. Irwin started from home on time but got stuck in traffic. He was late for work. He began to climb the bamboo scaffold in a hurry to reach his allocated work area and start his day. He picked up a harness with a broken belt. As his supervisor was observing him, his co-worker called out to him and indicated that his safety belt was not fastened. Irwin gestured that he was already late and he did not have time. Moreover, this was a short job and he would be down in no time. Suddenly, he slipped on the wet bamboo and fell onto the ground, resulting in a fatal injury. Why did the accident happen? Irwin, in a hurry, had failed to fasten the safety belt of his harness. Now, let us look at his scenario where a worker is walking at a height without a safety belt. Don't you agree that it can be dangerous? Safety precautions are very important while working at height. But the safety process does not start with the safety equipment. It starts much before in the planning stage of the project, where safety is built into the project. Let us now start from the beginning and learn more about ensuring safety while working at a height.
In the accident involving Arvind, it was the worker's mistake not to wear the belt, isn't it?
It was a mistake, but the mistake is not his alone. Whenever there is a job that requires work at a height, there should be a complete assessment of the personnel, equipment, and work surface. In this case, the worker was not trained and there was a faulty belt harness which should not have been there. In addition, the bamboo was slippery. So, there was an issue with the personnel, equipment, as well as the work area.
How do we prevent this from happening?
This can be prevented with systematic checking. Let us go through a checklist with the checks required on the equipment, personnel, structure, and work area. First, let us look at the checks for the equipment. The equipment and systems should be suitable for the job and should be in good condition. You need to check the following about the equipment and systems. Decide what particular equipment will be suitable for the job and the conditions on site. Check if the equipment and body harness are in good condition. If another company provides the equipment, ensure that is safe on site before using. Make sure that tested equipment and systems are used. Make sure that the equipment needed is delivered to site in good time. Next, we will look at all the checks required for the personnel. It is important that the personnel who are involved be trained and knowledgeable. Ensure that the personnel meet these requirements. Ensure that personnel who put the equipment together are trained and knowledgeable about the task. Make sure that the personnel who use the equipment are supervised so that they use it properly. For more specialized equipment, for example, Bostwain's chairs and rope access equipment or system, the greater will be the degree of training and supervision required to ensure safety. Identify the person who would be the point of contact if any defects needs to be remedied or modifications need to be made. Keep them informed about the operations. Finally, we will list the checkpoints for structural and work area. You need to check the following about the work area and platforms. Check if there is a safe method of getting to and from the work area. Check if the work platforms and any edges from which people are likely to fall have guard. Give due considerations to for scaffolding and ladder standards. For this, refer safety standard SS/ENGG-08 and SS/ENGG-09 for scaffolding. Create a proper sketcher scheme based on safety standards. On-site requirements, height of the work, and type of building or structures. This should be approved by a competent or qualified engineer of the execution department performing the job. Ensure that the site has been prepared for the job.
That is a lot of information. Isn't there a way to make sure that this and other requirements are satisfied?
Yes, there are many checks. Before the start of each job, a permit should be issued to the working agency. These factors and many others are considered before the permit is issued. Let us look at them now.
Before the start of a job, a work permit for working at height should be issued in form number EHSMSM/works/446/4007 or its revision by the authorized person of the department in duplicate. The original will be issued to working agency while the copy will be kept by the issuing authority. The issuing authority should perform several checks before giving the permit. Click on each skill to identify the checkpoints to be considered before the permit is issued. After you have read each of the items, move on to the next screen. Personal skill. Verify the following regarding the personnel. Is the person a certified rigger? Is the person fit for working at height? Does he have a certificate from doctor? Does the person have vertigo height phobia for working at height more than 2 meters? Is the person is trained on working at height? Suitability of approach. Check the physical condition and suitability of steps and rung ladders. Evaluate the scaffolding, ramps, stairs with respect to load. Suitability of platform. Verify if handrails are provided at 1 meter height with top rail, middle rail and toe guard. Check if extended support roof or working platform is fabricated or available. Assess if the secondary support is provided while working at fragile or hazardous roof. Availability of personal protective equipment, PPE and tools. The following personal protective equipment and tools should be available before the work starts. Helmet with chin stripes in working condition. Safety belt with double lanyard with arrangement for lifeline support. Fall arrestor. If a manila rope issued as lifeline or for any other purpose, it should be checked before each application when it is in use. The diameter should be ascertained before use and certified by a competent and qualified engineer of the department executing the job. The test procedure for manila rope will be same as being followed for all other construction tools and tackles.
It is not sufficient if the checks are done prior to the issue of the permit. The information should be conveyed to all the personnel involved, including the workers or mobile operators in the area, maintenance personnel, personnel managing the tools and equipment, and so on.
Really? I understand about the need for communication to the workers. What needs to be communicated to the others, such as maintenance personnel, mobile operators, and so on?
Let me explain. The tools, tackles, fixtures, fasteners, cages, rope ladders, plant and machinery, cranes, and so on to be used must be tested prior to use by the concerned person. So, this information must have been communicated to them. Appropriate anchorage points must be identified and connected. There may be hazard in the work vicinity, such as power line, power mobile, equipment, gas line, and so on. This must be identified and conveyed to the team planning the protective measures. This must also be communicated to persons expected to work at height. Operator of mobile equipment in the close vicinity should be informed about the job being done because they may need to take precautions. The area on ground beneath the height where job is being executed must be properly barricaded or fenced, indicating danger. Concerned departmental personnel whose work may get affected by the job must have been identified and communicated. Loose materials should not be kept at heights where the work would happen. Material at heights should be kept in an arranged manner to avoid slip, trip, fall hazards. Damaged, torn, bent scrap sheets should not be used on platforms. This should also be conveyed to the appropriate personnel. Tools, tackles, consumables, holders, and so on should be kept tied to avoid their fall.
That is a lot of information. Can we revisit the important points again?
Sure. Let us now summarize the important points.
Firstly, any work at a height should be carried out only in the presence of a supervisor. Only trained persons shall be allowed to work at height. Permit shall be issued only if the findings of the above checks satisfy the issuing authority.
Correct. In addition, if working at height includes gas cutting and welding, working in gaseous hazardous area near electrical installation, work permit should be obtained from authorized agencies separately for each hazard. The work permit shall be returned daily after completion of job. The work permit issuing authority of owing department after completion of the job should complete the form by the filling the part E in the original along with the white copy.
What can we do if a fall occurs in spite of all the best efforts?
Yes, that is possible. Let us now understand continuous fall protection. It is important and desirable to eliminate the fall hazard so that falls will not occur. However, it is also a very difficult task. So, fall protection goes beyond this and can be achieved through eliminating fall hazards, preventing falls, and finally controlling falls if they occur at all. If fall hazards cannot be entirely eliminated or prevented, then potential falls must be controlled by using fall arrest system.
I understand. Of course, all fall arrest systems should be purchased after consultation with the site safety specialist, isn't it?
Yes. Also, all components of fall arrest systems must meet the appropriate governmental regulations and consensus standards.
That means that fall protection is actually a three-step approach.
Yes, every site must take a three-step systematic approach to protecting people from falls. Let us now look at each of the steps in greater detail. The way to eliminate the fall hazard starts with the earliest design or engineering stages of project work and continue during the planning stages of all work. Addressing fall protection in the early phases of a project means that safety can be designed into the work process, not added as an afterthought to an inherently unsafe work procedure. The first step in this approach is to assess the workplace and the work carefully. Critically examine the workplace to identify the possible exposures to falls. Ask who, what, when, where, why, how, and how much. Questions about each possible exposure to a fall. This assessment of the site and the work not only helps eliminate hazards, but also identifies alternative approaches to the work that can measurably enhance productivity. Let us look at an example of how identifying alternate approaches can help. There was a project that required an assembly of a steel structure at a height. There were many risks involved and the chances of hazard were high. It would have required many fall prevention and control measures. Instead, we assessed the situation and came up with an alternate solution. The project was designed so that structural steel can be assembled at grade and then raised as a module, thus eliminating a significant amount of work at heights. Next, let us see where we get the correct information regarding the procedure to eliminate fall hazards. When the project is planned in-house, safety specialists may be involved early in the project planning. So, they can recommend appropriate fall protection measures and equipment. You can also use the expertise of fall protection equipment manufacturers and distributors. When working with contractors, we should ensure and insist that the contractors prepare written fall protection plans, especially with roofing work, construction of cooling towers, erection of steel structures, and fabrication and erection of tanks and boilers. Insist that fabricators supply permanent stairs and guardrails before steel is erected. In this way, the stairs and steel can be erected simultaneously, improving not only safety but also efficiency. If it is not possible to eliminate the fall hazard from the work environment, the next step will be to install protective equipment and provide training to prevent the fall hazards. The second line of defense in continuous fall protection is fall prevention. This also requires assessing the workplace and work processes. If fall hazards cannot be completely eliminated during the first step, try to prevent falls by improving the workplace. Avoid relying on a worker's behavior or fall arrest equipment to prevent injuries. If the answer is no for a given situation, then you will need
to take the following measures.
Some of the ways to prevent falls include: install stairs, guardrails, barriers, and travel restriction systems early for a safe work environment. Make sure that the temporary perimeter protection is effective. For example, when cable guardrails are used, weld the cable support brackets or drill holes in the columns while the steel is at the fabrication shop or on the ground at the worksite. Avoid welding cable supports after the steel has been erected. Check the design before drilling holes in the columns. Design and build permanent guardrail systems to meet the requirement of Tata Steel standard. Attach lifeline to steel column while the steel is on the ground to provide tie-offs for iron workers unless other methods of fall protection are provided. Provide work platforms for electricians who install cable trays and pull wires into elevated cable trays. Use complete scaffolds and aerial lifts to provide safe work platforms. Construct and install covers immediately after creating the holes. The third step, the last line of defense against falls, is to use fall arrest equipment. Use fall arrest equipment, however, only after determining that potential falls cannot be eliminated by changing work procedures or the workplace. Equipment such as harness, lanyards, shock absorbers, fall arresters, lifelines, anchorages, and safety nets can reduce the risk of injury if a fall occurs. If the answer is no for a given situation, then you will need to use fall arrest equipment such as harness, lanyards, shock absorbers, fall arresters, lifelines, anchorages, safety nets, an automated control descent device that limits descent speed to 6 feet, 1.8 meters per second for a 300-pound, 136 kilogram person should be used in all situations that require emergency egress. Carefully assess the workplace and work processes to select the most appropriate equipment and to install and use it correctly. Before we move on, let us look at a photograph of a safety violation in a plant. Can you identify the area of safety violation?
Yes. I can see that the worker is removing his lanyard so that he can move to the next ladder. This can result in a fall as the worker is unprotected.
Correct. A worker should never be without their required fall protection equipment. It is beneficial to have a written plan so that these factors are not missed. Let us now move on to see the situations where a written plan will be needed.
Is it always required to create a written fall protection plan?
Fall protection plans should be prepared for elevated work if fall hazards exist. Where fall hazards are significant, the plans should be in writing. Site management or supervision are responsible for determining which jobs require written plans. The requirement for written plans should be included in all applicable contracts.
Since the fall protection plan is the last line of defense, I am sure due diligence should be exercised in deciding the personal fall protection. Let us understand the components of the fall protection plan next.
Personal fall arrest system consists of an anchorage, connectors, a full body harness, and may include a lanyard with locking snap hook, deceleration device, lifeline, or suitable combination of these. The use of body belt for fall protection is prohibited. Move on to learn about the checkpoints deciding on a personal fall protection system.
Before using a personal fall arrest system, the supervisor and/or the user must address the following questions. Has the user been trained to recognize fall hazards and to use a personal fall arrest system properly? Are all components of the system compatible according to the manufacturer's instructions? Have appropriate anchorage points and attachment techniques been reviewed? Has the free fall distance been considered so that a worker will not strike a lower surface or object before the fall is arrested? Have pendulum swing fall hazards been eliminated? Have safe methods to retrieve fallen workers been planned? Have the full body harness and all of its components been inspected both before each use and on a quarterly basis? Is any of the equipment, including lanyards, connectors, and lifelines, subject to such problems as welding damage, chemical corrosion, or sandblasts? Let us now look at another scenario of safety violation.
Can you identify the area of safety violation?
The workers were coming down from 10-meter height through rung ladder, neither using fall arrestor, not available, nor hooking the safety belt at C11 and C10 respectively. This could lead to a fall and a fatality.
Every vertically fixed rung ladder should have an attached fall arrestor. All workers moving up and down through ladder must use the same equipment.
Sumit was a very skilled construction worker and was employed several times for working at a height. On an assignment, he climbed a scaffold to work on a tower. He was wearing a retractable lifeline as required. However, he had a fatal fall and succumbed to his injuries. Why did this happen? After an investigation into the incident, it became known that he did not inspect the quality of the lifeline, which was faulty, nor did he consider the fact that it had already been used as a fall arrestor once. These are some important details that could make a difference between life and death. Let's have a close look at a few points which we need to consider when using retractable lifelines.
A retraceable lifeline is a fall arrest device that is used in conjunction with other components of a fall arrest system. A properly inspected and maintained retraceable lifeline, when correctly installed and used within the fall arrest system, automatically stops a person's descent in a short distance after the onset of a fall.
Can you elaborate on what you mean by properly inspected and maintained?
It is very important that the retraceable lifeline be properly inspected, maintained and used correctly. Otherwise, it will fail to provide protection, as in the case of Sunil. Let us look at the do's and don'ts of using a retraceable lifeline now. First, let us look at the correct way of using them. A retraceable lifeline should be used by only one person at a time. The retraceable lifeline must be connected directly to the back D-ring of the safety harness. Now, for the incorrect ways of using them. The retraceable lifeline should never be used in conjunction with a shock-absorbing lanyard. It should never be connected to a shock-absorbing lanyard either. Retraceable lifeline must not be used again after it has worked as fall arrestor 1.
That was very important information. Because of its criticality in fall control, supervisor should employ some checkpoints before using it.
Before using a retraceable lifeline, the supervisor and the user must address the following questions. Has the user been trained to use a retraceable lifeline correctly? Is the retraceable lifeline being used in conjunction with a correctly configured fall arrest system? Is the equipment under a regular maintenance program?
Next, let us look at the situations where these should be used.
Consider using retraceable lifelines when working in or on areas such as roofs, scaffolds, tanks, towers, vessels, and manholes. Also, Consider using retraceable lifelines when climbing equipment such as vertical fixed and portable ladders and telescoping derricks.
Thank you, Syed, for the information. Next, let us look into the safety system for ladders.
A ladder safety system can be attached to a permanently installed ladder or to a rigidly installed portable ladder.
How does the ladder safety system work?
The system provides continuous protection while a person ascends or descends the ladder by automatically locking and arresting a fall. Let us now look at a scenario where there was a violation of safety measures in the use of retraceable lifelines and ladders. Identify the safety violation and describe the correct way to do the task.
Can you identify the area of safety violation?
We can see here that the worker is moving from one ladder to another. The ladders are not properly aligned. Moreover, the upper segment of the ladder is not properly fixed at 5-meter height. It is unstable. The consequence of this could be a fall.
For height jobs, lifeline must be provided and the person should anchor the lanyard of the full body harness to the lifeline. The ladder must be extended 1 meter above the landing area. Landing area must be free from projected nails and other hazards.
Safety net system. Sugriv was working at a height when he suddenly tripped and fell. A safety net was installed, but he still struck the ground and lost his life. Why did this happen? The reason was that the safety net was not installed appropriately as per the instruction manual. These accidents can be prevented by ensuring the use of appropriate safety net systems. Sugriv was working at a height when he suddenly tripped and fell. A safety net was installed, but he still struck the ground and lost his life. Why did this happen? The reason was that the safety net was not installed appropriately as per the instruction manual. These accidents can be prevented by ensuring the use of appropriate safety net systems.
Isn't the safety net supposed to be the backup if all else fails? Why didn't it help Sugriv?
A safety net system is the least desirable fall arrest system. The safety nets are suspended below the work area, where there is a chance of a fall. They provide a soft landing for the faller and minimize injury.
Are there any guidelines as to where the safety net must be installed?
A safety net system must never be more than 30 feet or 9.1 meter below the working surface, except for bridge, gallery or structural frame construction. If the safety net is below a work area where no gas cutting and welding jobs are done, the system must be installed as close as practical under the walking or working surface. On the other hand, if there is an overhead gas cutting and welding activity, fireproof tested nets are to be used.
How can we be sure that the safety net will withstand the fall?
This is determined through the drop test. Let us look at that next. Safety nets shall be capable of absorbing an impact force equal to that produced by a drop test. The test, if practicable and safe to drop bag of sand as specified, shall be conducted by dropping a 400-pound or 180 kg bag of sand of 30 plus or minus 2 inches in diameter into the net from the highest working or working surface at which employees are exposed to fall hazard. The drop distance shall never be less than 42 inches above the next level. A drop test must be conducted after initial installation and before use, whenever relocated, after major repair, and at 6-month intervals if left in one place.
In addition, the safety nets should be inspected regularly. Safety nets should be inspected at least once a week for wear, damage, and other deterioration. Materials, scrap pieces, and the equipment and tools which have fallen into the safety net shall be removed as soon as possible, but at least before the next work shift. This will help to prevent fatalities due to the failure of the safety nets.
Do you recall that we learned about the lifelines in the previous course?
Yes, horizontal lifelines allow horizontal movement while providing protection against falls. A horizontal lifeline may serve as a mobile fixture point for the attachment of lanyards, lifelines, or retractable lifelines. A lifeline must be wire rope of at least ½ inch or 1.20 centimeter diameter.
Correct. The horizontal lifelines should be properly installed and used. It is important that horizontal and vertical lifelines shall be designed, installed, and used under the supervision of a qualified person as part of a complete personnel fall arrest system. Let us look at the usage guidelines of lifelines. The lifelines in the previous course?
Yes, horizontal lifelines allow horizontal movement while providing protection against falls. A horizontal lifeline may serve as a mobile fixture point for the attachment of lanyards, lifelines, or retractable lifelines. A lifeline must be wire rope of at least ½ inch or 1.20 centimeter diameter.
Correct. The horizontal lifelines should be properly installed and used. It is important that horizontal and vertical lifelines shall be designed, installed, and used under the supervision of a qualified person as part of a complete personnel fall arrest system. Let us look at the usage guidelines of lifelines. Let us look at the horizontal and vertical lifelines installation process. The wire rope sling is equipped with thimble. There is a minimum of 3 cable clips. The direction of installation shall be correct. The distance between the cable clips shall be the same. Not more than 2 persons shall be permitted to attach their lanyards to a single horizontal lifeline at one time. The lifeline shall be anchored between 2 posts or supports not more than 6 meters apart. If intermediate post required to be put a spacing more than 6 meter, proper anchoring, post or support and lifeline arrangement should be made as per sketches with approval of competent and qualified engineer of the executing department performing and supervising the job. Vertical lifelines extend from an overhead independent anchorage. They should be maintained in a vertical position while in use. A lanyard is attached to a vertical lifeline using a rope grab device. No more than one person may tie off to a vertical lifeline. Can you identify the area of safety violation?
There is a gap in the wire rope between the two lifeline posts at a height of 10 meters. This appears to be greater than 2 meters. The person may fall when they try to move from one line to the other without anchoring his lanyard.
Lifeline should be continuous so that the person remains secured all the time by anchoring his lanyard with the lifeline while working at height.
As you would recall from the definitions, anchorages provide a secure point of attachment and are a key component of the personal fall arrest system. Anchorages used for the attachment of personal fall arrest equipment should be independent of any anchorage being used to support or suspend platforms. Here are some guidelines regarding their use. Anchorages must be capable of supporting at least 2,000 kilograms per employee attached. If they are not, then they should be designed, installed and used as follows. They should be a part of a complete personal fall arrest system that maintains a safety factor of at least 2. They should be used under the supervision of a competent and qualified person. The anchorage points should be certified by a competent and qualified engineer of the department, executing and supervising the job.
Can you identify the area of safety violation?
The lifeline wire rope has been tied with 12 mm reinforcement bar, separated by about 10 meters, and 2 persons have anchored their lanyard with the same lifeline. As per standard, the anchorage point should be capable of supporting at least 2,000 kilograms per person attached.
The lifeline must be tied with a fixed or a permanent structure having the capacity to support at least 2,000 kilograms per person attached.
Safety checks while dealing with scaffolds. Raghav was not trained in erecting and dismantling scaffolds, but he was asked to dismantle the scaffold. As he was dismantling, the scaffold fell because of the detachment of the angle bracket and Raghav fell to his death. Let us look at some scenarios which are common scenes of dangerous falls. We will also see some remedial actions to prevent falls. Safety check. Safety checks while dealing with scaffolds. To prevent falls. The tasks and situations listed in this section present inherent fall hazards. You should give special attention to providing fall prevention and fall control for these tasks. Remember that this attention is necessary in the design, engineering, planning, and execution stages of work. The most common and dangerous tasks include installing, painting, and insulating pipe systems such as overhead cranes, presses, furnaces, conveyors and monorails. Tank erection, form work, masonry work and work above ceilings are also hazard prone. Let us now look at some of the common and dangerous falls. Click on each task to learn about the fall protection measures in each of the tasks. Erecting and dismantling scaffolds. Special consideration should be given to fall protection for workers who assemble and disassemble scaffolds. Make sure workers who install, dismantle, inspect, maintain and use scaffolds receive appropriate instructions including relevant requirements. Double lanyards where employees connect one lanyard to a suitable anchorage point before disconnecting the other lanyard are used in these cases. Pile driving. Pile driving work at Tata Steel should always done by specialized contractors. These contractors are required to provide written fall protection plans. Refer Safety Standard SS/ENGG 12 on piling operation. Pile driving tripod structure must be stable and each leg must have access provision. The drawing of the tripod structure must be approved by the competent and qualified engineer of the executing department. The executing department refers to the department which has engaged their engineers to carry out and supervise the job. Erecting cooling towers. Contractors working on Tata Steel facilities must provide adequate access and egress, lifelines, temporary perimeter protection, and other fall protection for those who are erecting a cooling tower. Contracts must provide a written fall protection plan. Working in confined spaces. Before assigning or performing work in confined spaces, the supervisor and the worker must ensure safety by addressing questions in addition to requirements of safety standard SS/PRO 01, such as the following. Can the fall hazard be eliminated by providing entry at ground level rather than at the top of the confined space? Can a rescue worker with a self-confined breathing apparatus fit through the entry opening? Have emergency situation fall hazards been anticipated? For example, if steam is inadvertently introduced, will it strike the ladder? Will it strike the path of egress? Has the use of a tripod-mounted personnel hoist instead of a manual lift been considered for retrieving workers from confined spaces? Next, let us look at the final level of defense in the form of personal protective equipment in these cases. In these cases, elimination of the fall hazard will be difficult. The use of completed scaffolds, aerial lifts, and so on can minimize the hazard but many not eliminate it totally. The use of personal fall arrest equipment is required. The use of double lanyards is required to achieve 100% fall protection. This allows workers to move from one location to another, but also keeps them secured at all times. This is achieved by the employee connecting one lanyard to a suitable anchorage point before disconnecting the other lanyard.
Can you identify the area of safety violation?
The worker is working near opening at 6-meter height without anchoring his lanyard. This could result in a fall.
The person has to anchor his lanyard with a lifeline or with an adequately protected platform.
Moving on, let us learn about the portable scaffolds. A mobile or portable scaffold is a type of freestanding scaffold supported on wheels, casters, or other devices for ease of movement on a firm level supporting structure. Mobile scaffolds can be erected from a variety of components or systems, including aluminium prefabricated systems, fiberglass prefabricated systems, non-conductive, steel frame scaffolds, H-frame, system or modular steel scaffolds, tube and fitting scaffolds.
Portable scaffolds can be safe if they are maintained and used appropriately. Let us look at some important points to be considered while dealing with portable scaffolds.
Some important points to remember when dealing with mobile scaffolds include: if they are more than 5 meters in height, they should be erected, maintained, altered and dismantled by a certificated scaffolder of the correct class. If they are less than 5 meters, they should be erected, maintained, altered and dismantled by a competent person. They should be erected to the manufacturer's instructions. They should be used on a sound, clear and level surface. Ensure working platforms are decked to the full width and adequately restrained against displacement. Ensure top and mid-guard rails are erected on platforms. Erect platform toe boards to prevent items on the platform falling on people below. Provide safe means of access to work platforms. Where the platform incorporates a hatch door, ensure the hatch is closed except during access or egress.
These will provide fall protection measures. However, all scaffolds, especially mobile scaffolds, can be unstable due to their structure.
All freestanding scaffolds, whether mobile or static, need to be stabilized against overturning forces. Mobile scaffolds in particular are prone to tip over during use for a variety of reasons. The mobile scaffolds can tip over when there are sudden stops while it is being moved. This is a key reason why they must not be ridden while being moved. The height of the topmost platform is greater than 3 times the minimum base dimension, making it unstable. People standing at or near the edge of the platform, combined with a sudden movement or action, creates a temporary high loading point. Capacity of the portable scaffolds is based on a distributed load, not a point load at the edge. This means overturning can occur even when the design load capacity of the platform is not exceeded. The narrower and lighter the scaffold, the more likely that it will tip over.
Let us now understand how we can improve the stability of scaffolds. First, let us look at the general considerations for stability.
These are some of the general principles to improve stability. The height of the top working platform must be no more than 3 times the minimum base dimension of the structure for scaffolds over 1.8 meters in height. The height of the top working platform must be no more than 2 times the minimum base dimension of the structure for scaffolds less than 1.8 meters in height. Rakers outriggers or larger base frames to increase the minimum base dimension if required. Mobile scaffolds generally need to be braced on all sides. All mobiles must also be plan braced to prevent the tower from deforming in shape, that is, parallelogram, except in the case of a mobile aluminium framed scaffold where the lowest fully decked platform is below 3 meters high. Remember, these base to height ratios are only acceptable under normal weather conditions. Additional precautions must be taken if adverse weather conditions are expected. Next, let us look at some specific precautions to improve stability which apply to mobile scaffolds. Position the scaffold as close as possible to the area being worked on. Apply the caster brakes while the scaffold is in use. Don't ride the scaffold while it is being moved. Maintain the height to width ratio. Use outrigger bracing. Add weight to the scaffold base to improve stability. Establish with the manufacturer exactly what the established safe working load relates to. Where possible, use alternative more stable equipment such as a scissor hoist.
While using portable scaffolds, check if the casters satisfy the following condition. Can they support the dead and live loads imposed upon the scaffold? Are they a minimum of 125 mm in diameter and secure to the standard? This can be done by using an expanding internal spigot that fits into the standard or by using a locking device on a sleeve-type external fitting over the standard. This is to prevent a caster from falling out of the standard when wheeled over uneven surfaces. Do they have the SWL, safe working load clear, shown on them? Do they have some kind of braking or locking system? This can come in a range of types such as screw and compression devices on the actual caster itself. Do they have a minimum 150 mm spigot or pintle length, internal spigot length or external socket length, in or over the standard?
Adjustable casters have a few additional requirements. Let us look at them now.
Adjustable casters have the same requirements as a normal caster but can be adjusted vertically by way of a threaded spigot or stem with a positioning nut. The threaded extension, while maintaining a minimum of 150 mm spigot or pintle length in or over the standard, must not exceed 600 mm adjustment. Casters can also be used horizontally as a running device to keep a mobile scaffold off a surface. It is recommended that the threaded extension, while maintaining a minimum 150 mm spigot or pintle length in or over the standard, should have a maximum extension that does not exceed half of the total extension. For example, a caster with 500 mm extension should preferably be kept to a maximum of 250 mm extension, but can be used out to 350 mm extension. Adjustable casters do not need to be secured to the standard if the spigot or pintle length is greater than 300 mm. Let us now look at some of the commonly used portable scaffolds.
Double deck with mobile scaffold. 5 deck wide mobile scaffold. Double deck with mobile scaffold with base. 2 deck mobile with proprietary bridge. Frame mobile tower. System mobile tower.